Assalamualaikum warahmatullahi wabarakatuh. My name is Nadzmi bin Ahmad Kamal, BE20303-MULTIVARIABLE. I'm from Group 6 for the project of Multivariable Calculus BE20303, and I will start present my part, which is question 1A and question 1B. We will compare the final answer for the manual calculation with the simulation. So for the first question, which is question 1A1, I have to compute the multiple integral of this equation, and I have obtained the final answer of 203 over 120. So based on the simulation that I have done, it is shown that the final answer is 203 over 120. So it is proved that final answer of the manual calculation and the simulation is similar. Then for the next question, which is question 1A2, so this is the question and this is the value of R given, and I have obtained the final answer of the 76 over 3. And for the simulation, after I have insert all the value or the equation, and the answer is 76 over 3. So the answer is similar to the manual calculation that I have done. So for the next question, so evaluate the following triple integral by using the spherical coordinate. So here I am changing from the Cartesian to the spherical coordinate, and also I'm changing from this equation into this equation. So the final answer I have obtained is 6396.1, and for the simulation, I'm using the equation that I have transformed from the Cartesian to the spherical, which is here is the spherical coordinate, and the final answer shown that 6396.1, which is similar to the manual calculation that I have done. So based on the three activities that I have done, I am doing simulation by using the Wolfram Alpha. So that's all from me. Thank you.
Assalamualaikum. My name is Haniza Binti Arman. I'm going to explain about the question number 1, C, 1 and 2. Question number 3, C. Okay, for the first one, I'm going to explain about the question C, C1, question 1, C1. So, this is my calculation for C, question 1, C1. Which is this is my final answer for question 1 C1. Okay, when I do the simulation, so I get the similar answer for question 1 C1. Okay, so moving to the next question, which is question number 1 C2. Alright, this is my final answer for question 1 C2. So the same method that I do for question C2, question 1 C2. Okay, here is I put a value at the variable and so on. So as we can see, we get the similar answer to my similar answer with my manual calculation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nureen Sofiya binti Muhyedin. My metric number is CE2047. So I'm going to show how to do the simulation for question 2A and 2B. For question 2A, we need to find the first partial derivative of first x to the power of 2 over z to the power of 3. Second, exponent to the power yz cos xy. For question 2A, I'm going to use MATLAB software to prove the answer. So now I'm going to show for the question 2A first. Now I already put the according and also the equation for this question. So the first one, we differentiate the function towards x, and the answer is 2xy over z to the power of 3. And the second one is we differentiate the function towards y, and the answer is x to the power of 2 over z to the power of 3. And the last one, we differentiate the function towards z, and the answer is negative 3x to the power of 2y over z to the power of 4. Now we do for the question 2a2. Next, the second equation is exponent to the power y z cos xy. And now we differentiate first the function towards x, and the answer is negative y exponent to the power of yz sin xy. And next, I differentiate the function towards y, and the function is z exponent yz cos xy minus x exponent yz sin xy. And the last one, I differentiate the function towards z, and the answer is y exponent yz cos xy. Next, for question 2b, we need to solve del z over del u and del z over del v by applying chain rule if z equal to the ln x to the power of 2 minus 2y, x equal to u plus v, and y equal to exponent to the power of v. For question 2b, I'm going to use Maple to prove the answer. And this is how to find the answer for del z over del u, which is first one, I enter the equation, which is z equal to the ln x to the power of 2 minus 2y, and I differentiate del z over del x, and I got this answer. As for x equation is u plus v, and I differentiate del z over del u, and I got 1. And I differentiate del z over del y, and I got this answer. And I enter another equation, which is y equal to exponent to the power of v, and I differentiate del z over del u, and I got 0. And after that, this is the final answer for del z over del u. Next, I'm going to show how to get the answer for del z over del v. So this is how to get the answer for del z over del v, which is I already put all the equation given, which is z equal to ln x to the power of 2 minus 2y, x equal to u plus v, and y equal to exponent to the power of v. And then I differentiate del z over del x, and this is the answer. And then I differentiate del z over del y, and then this is the answer. And then I differentiate del x over del v, and then I get 1. And the last one, I differentiate del y over del v, and I got exponent to the power of v. So after that, this is the final answer for del z over del v.
Assalamualaikum warahmatullahi wabarakatuh. So for the next question, question 2c, this is the simulation. So first, I just write the answer, the question, which is the exponent the power of x sin y plus exponent y cos x, and then put delta squared over delta x squared as the calculation at the right side. Then just click go, and got the answer sin y exponent x minus exponent y cos x. So for the first step, the answer is proof. And then for the next step, I find the delta squared z over delta y squared. So and then just also type the question and just change to delta squared over delta y squared. Then after that, we click go and get the answer negative exponent x sin y plus cos x exponent y. The answer also same as the calculation, so it is proof. Then both of them, just add both of the equation, and we will get the answer is 0. Since the answer is 0, so the function for z equal to exponent x sin y plus exponent y cos x satisfies the Laplace equation. So next, for the question D1, this is the manual calculation, and this is the answer. So for the answer, I obtained by determine the fx and fz. So to get the fx for the simulation, just type like this. It is just put the equation that we got from the state from the question, which is y to the power of y exponent to the power of xz minus 3y exponent to the power of yz plus 4z exponent to the power of xy minus 1. And then just put delta over delta x, click go, and then it will get the answer equal to exponent to the power of xx yz plus 4 exponent of yx yz. This is the answer for both calculation and simulation is same, so it is proof. Same also for the fz. Just change at the delta over delta z. The answer also got same as the for both calculation and simulation, also same. Then since we know that delta z over delta x equal to negative fx over fz, just put the both equation, and we got the answer for this question. I tried to simplify it by the simulation, but it could not simplify furthermore, so this is the last answer, the final answer. So next for the question D2, at the right side of the window, this is the calculation, same method as the question 2-1. So for the simulation, just put for the delta over delta x, just put the equation from the question, which is 2x squared z to the power 4 minus 5 ln xyz squared minus 4z. Then just click go. It will show the answer, 4x z to the power 4 minus 5 over x. The answer also similar like the calculation. So for the fx, it is proved. And then for the fz, also do the same method. Just change delta over delta z. Click for the simulation, and then put the equation. Click go, and then after that we click go. It will show the answer 8x squared z to the power of 3 minus 10 over z minus 4. For the calculation also got the same answer. Hence delta z over delta x equal to negative fx over fz. So this is the answer. Try to simplify it by using the simulation, and we got the answer is equal to negative 4x squared z to the power of 4 minus 5 z, and then over x 8x squared z to the power 4 minus 10 minus 4z. So both for the both answer show the same value, so it is proof.
Assalamualaikum, my name is M.Rifqi Aiman bin Azizan. My matric number is BE20303-MULTIVARIABLE. I'm from section 4. Today I will explain to get the final answer for question 3A and question 3B. Now first I will explain the final answer for question 3A by manual calculation. Alright, this is the step that we need to find the final answer for question 3A, which is step 1 by use a curl of vector formula. So this is the answer. And then step 2, by using a formula, the divergence of curl vector, this is the formula, we apply it and we will get the final answer is divergence of curl vector is equal to 0. Now I will show you by using MATLAB as a proof that is it similar or not with the manual calculation. So we need to set the parameter in x, y and z, and then this is the vector. Alright, then we will get the final answer is 0. Now I can conclude that the result in simulation and manual calculation is similar. Alright, next I will show you the calculation or final answer for question 3B. Alright, this is manual calculation for question 3B. So this is the vector, f vector, and then first step we need to use this formula, which is f vector f times dr. So this is the dr, which is delta xi plus delta yj. Alright, after we use the formula, so the answer is negative pi power of 3. And now to show whether the f vector is conservative or not conservative, we need to use a curl vector formula, which is this is the formula. We apply it and then we will get the answer 0i plus 0j and plus 0k. So from this we will conclude that f vector is equal to 0 and is a conservative. Now we need to prove it using a MATLAB simulation. So same like question 3a, use parameter in x, y and z. This is the vector f, and then we need to integrate the 3x power of 2 by 0 to negative pi. So we get the value negative pi power of 3, and then we need to integrate y power of 2 by 0 to 0. So we will get the answer is still negative pi power of 3. So to prove that the vector f is conservative or not, we need to use a curl vector formula. So we apply it like this. So we will get the final answer is 0i, 0j plus and 0k. So I can conclude this that the final answer by using MATLAB and manual calculation is similar too. That's all from me. Thank you.
Alright, moving to my last question, which is question number 3. So question number 3C. So for this question, I just draw this cone for my imaginary. So after I calculate the question, this is my final answer for question number 3C, which is 32,805 over 2 pi. Okay, so for this question, I'm using Wolfram Mathematica. So this is the simulation that I do to get the final answer. So as we can see, my final answer for this question also similar with my manual calculation. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiqah Binti Abdul Talib. My matrix number BE20303-MULTIVARIABLE and I will do the simulation for question 4B and also for C. So the first question for 4B is to sketch the graph of the surface. So the graph that we will get will be looks like this, where we have a coin and also we have a cylinder. The second question is to find the divergence of vector f. So I use MATLAB. So first is we declare x, y, z, and then fill is the value for each vector, and then vars is the variable which is x, y, z, and then to get the divergence we just declare divergence, fill comma vars, and then we get the answer which is x plus 1 for the divergence of vector f. Next question is to evaluate the flux of the vector field by using Gauss theorem. So first we need to integral the divergence, and then we will get x plus 1 multiple with the square root x square plus y square, and then from this we change it to the polar form. So we will get r cos theta plus 1, this for x plus 1, and x square plus y square, square root x square plus y square, we will get r. So this is r for the this one, and then we multiple with the r dr d theta, and then from this I will simulate to get the answer. So I use the symbol lab. So first is the integral is with the respect to the r, and then the second one is the respect to the theta. So the limit for r is between 0 until 2, and for the theta is 0 until 2 pi, and then we simulate, so we will get the answer is 16 pi over 3. Okay, next question is for C. Okay, so the first question is also to sketch the surface of the plane. So the given plane is x plus y plus z equal to 1 with C, triangle C with vertex 1, 0, 0, 0, 1, 0, and 0, 0, 1. So the graph that we will get will be looks like this. Okay, so this is the graph, and the triangle is as we can see on the xy plane with the coordinate 1 for x and also 1 for y. Okay, next we need to evaluate by using Stokes theorem. So for this one, we need to find the divergence of the vector f first. So by to find the divergence, we use the method of matrix, and then we will get the divergence is zi plus yk. Okay, and then after that we need to find the n value, which is n is unit normal vector. We also use matrix method. So for the value of n, we will get k plus j plus I, same as this one also, I plus j plus k. And then after that, before we do the integral, okay, we need to do the dot product first between divergence and also n. So the value that we will get for this one is z plus y. Okay, the dot product's value is z plus y, same as this one also. So after that, from the question given, we have the equation which is x plus y plus z is equal to 1. So from this equation, we convert the value for z into this. So so the z we will get is y minus x minus y. So y minus x minus y we convert or we insert to the z value. Okay, after that we will do the integral, which is we get y minus x. So we integrate to the respect of y with the limits 0 until y minus x, and x is 0 until 1. So after that, when we integrate this, we will get 1/3. So that's all from our group. Thank you.